Discovery after discovery was, yes, check this off for habitability on Enceladus, check that off, check that off, check that off. Went through the entire list and discovered all these things. And now it's time to go back there and actually look to see if it's not just a habitable environment, is it inhabited? Is there life?
This is Ithaca, New York, home to the astronomy department of Cornell University. Here works a man who will either land up in the history books as one who found the first evidence for alien life in our solar system, or he will not. He is working on a mission to Enceladus, a moon of Saturn, and his name is Jonathan Lunine, and I have come here to talk to him. Why should we go to Enceladus?
We should go to Enceladus because it's the one place that we really know has a habitable environment. Everything that you need to know to determine whether something is habitable, liquid water, organics, energy sources, salts, we know it's there.
Enceladus goes around Saturn. It is a fairly small icy world and would easily fit between Amsterdam and Berlin. Enceladus is often compared to another ice ball called Europa. They both have a liquid ocean under their icy cover. But Europa goes around Jupiter and Enceladus hangs around Saturn. For the past 20 years, most of the buzz was around Europa because we thought there wasn't much going on in Enceladus. But in recent years, the two have been in a battle for attention. Huge plumes were seen shooting up from Enceladus. A spacecraft called Cassini was in the neighborhood and was sent to Enceladus. It flew through the plumes and detected organic molecules, the bricks needed to lay the cathedral that is life. And is it better than Europa?
Yeah, we don't know whether there are organic molecules in the ocean of Europa. We don't know that. And we have circumstantial evidence for a hydrothermal system on Enceladus. We don't on Europa.
It's interesting because Europa seemed to be like the holy grail in our solar system for a while.
Yes.
When it comes to life, but Enceladus, was it more recently that it started?
Yeah,
popping up,
it's the fact that it was more recent. You know, Galileo, the orbiter, not the scientist, discovered almost inarguable evidence for a liquid water ocean under Europa in the mid-1990s. It would be another almost 10 years before Cassini discovered a plume coming out of Enceladus. We were all planning for a quick follow-up mission to Europa. I worked on an instrument, and for various reasons that had nothing to do with the science, we're still waiting for a mission to Europa. Meanwhile, Cassini arrives at Saturn, discovers a plume at Enceladus, flies through the plume multiple times, discovers all this evidence for habitability.
So now the race to find life beyond Earth is on, but we simply do not know the answer yet. NASA seems really confident though. In 2015, the head scientist of the American Space Administration made a rather bold statement. Ellen Stofan said that if you're alive today, the chance of you witnessing the moment humans find extraterrestrial life is fairly huge.
Well, I'm going to go out a little bit on a limb here, and I'm going to say I think we're going to have strong indications of life beyond Earth within a decade. And I think we're going to have definitive evidence within 20 to 30 years. We know where to look. We know how to look. In most cases, we have the technology, and we're on a path to implementing it.
And Stofan is most certainly also talking about the mission that Lunine is drafting.
So the Enceladus Life Finder mission, we would launch a spacecraft to Saturn. It would go into orbit around Saturn, just the way that Cassini did in 2004. It would set up a series of flybys with Enceladus by using the gravity of Titan, and we would fly through the plume of Enceladus 10 times, 10 orbits, sampling the material every time with two kinds of mass spectrometers. These are devices that essentially sniff or they taste the gas and the ice to determine the composition, and they would, with that material, determine whether biological processes are going on, that is life, determine the details of how habitable, what is the acidity, what is the oxidation state, what is the temperature of the interior ocean, all from this plume, and also tell us something about how Enceladus formed, which planetary scientists want to know. But the key goal is to find or to look for and identify molecules that are being produced by biology.
If these moons are indeed inhabited, it will be a monumental moment in human history.
We see ELF as opening the door to the exploration of the first extraterrestrial biota ever discovered, if it's there.
If it's there, it'll probably be Nobel Prize material.
Well, that would be terrific. But you know what? That's really not why I'm doing this. I'm really doing this because I just want to know if there is life beyond the Earth with a separate origin. I'd like to know that. And looking at the time it takes to explore the outer solar system, it gives those of us who are middle-aged a chance to actually find out whether life really exists beyond the Earth. And that's really what's important, to be honest. Not a trip to Stockholm.
Thanks so much.
Well, you're very welcome.
If you're interested in how scientists can detect life with a robot, check out the full interview here. And if you'd like to watch more videos about this new space age we live in, please subscribe.